Hello everyone. In this video, I will be covering for your FE Civil in your um, concrete design part, and this is beam shear. Okay, so what are the things? Let's look at what are the things that we know or we need to know for beam shear. For beam shear, there are three information that we need to know. One is design capacity for shear or design shear capacity, which means that how much of the concrete and steel can resist the shear. So this is your 5 VN, which is your shear capacity, and VN is nominal shear capacity, which means that the maximum shear that your beam can provide. And phi, in this case, your phi will be 0.75, which is given in your FE manual for your shear design. And then what is VN? VN, because this is a reinforced concrete design, so that means steel also will resist the shear. So it is a combination of your concrete. Concrete can resist its own, can provide shear capacity also, or shear strength, plus Vs, and Vs is from your stirrups. Okay, in this case these are your stirrups, and remember this is your main longitudinal bar which will resist your bending moment, and these are your stirrups which resist your um, shear force. Okay, so now VC is given in your FE manual. Is the um, value for finding VC is 2 lambda square root of FC BW into D. Okay, and what is lambda? Lambda is your factor that whether you're using normal weight concrete or lightweight concrete. And what is BW? BW is your width of web. Remember that if it is a T beam, your T beam, this is BW, which is the width of web. But in rectangle, this is B, which is equal to BW. So that is your BW, and D is your effective depth. And in this case, effective depth will be the CG of your steel to the top layer in your compression, and that will be your D, or effective depth. And so that is your equation. Again, this equation is given in your FE manual. And then what is VS? VS is a shear stress provided by the stirrups, and this is equal to AV, which is area of your stirrups, and then Fy into D divided by S, and S means spacing of stirrups center to center. Okay, so in your beam, if this is your uh, beam, and we know that this is your main longitudinal bar, and then we say that the stirrups you provided, and this is your S. Okay, or your spacing of your stirrup reinforcement. Okay, so that's what you need to know for your design uh, shear capacity. Okay, and then another thing that you need to know is um, for safe design, your shear capacity should be greater than your factor shear force, and in this case is BU. So just like we have for moment MU, we also have shear VU, which is your design shear load, and this will come from your maximum shear capacity or maximum shear load applied to your beam. And then there you have to do the load combination to find the maximum shear force. Okay, so let's look at this equation. This equation, you'll see that it says that for a singly reinforced concrete beam means you provided reinforce only in one side. So this is called singly reinforced. And then it has, this is actually 40,000, uh, not 40,000, this is 4,000 psi. And then your strength of your steel is 60,000. And what is the nearly ultimate shear strength or um, design shear strength provided by the concrete and stirrups? And you have given here that the stirrups are given to you, which is number 3, and then the spacing of stirrups is 12-inch center to center, and clear cover is 1.5 inch. Sometimes you can have an additional information, which you'll see that this information is not relevant for our calculation, but in case, if in case you need to find effective depth, then this clear cover is important, because you'll see that effective depth is clear cover plus CG, that will be your distance, and then the total height minus this distance effective clear cover, you'll get effective depth D. So remember that sometimes you may expect to have a total depth H, and H minus effective clear cover will be equal to D, and effective clear cover is clear cover plus the CG, the distance of the half of the diameter of the bar will be your effective clear cover. And if you take H minus effective clear cover, you'll get effective depth. Okay, and then VU is your factor moment, which comes from your maximum shear force. So for this question, all we need to find is what is phi Vn, and we know that Vn is equal to Vc plus Vs, and Vc is 2 lambda square root of Fc dash Pw into D, and lambda is not for a normal weight concrete will be equal to 1. And so if we put all the force together, you should get here 75135 pound, and if we convert it divided by 1000, we should get 75.14 kips. And then Vs is equal to Av and Fy D divided by S. And what is AV? AV is area of stirrups, and in this case, because we provided the stirrups on both sides, this is considered one leg, and this also on the other side, this also considered one leg. So we have double leg, and if it is double leg, this would be 2 of area of number 3, and area of number 3 is 0.11, and that will be 0.22 inch square. This is where this thing is important. um, if you uh, uh, if you by mistake using single leg, then you'll get wrong answer. So remember that this is double leg because we provided in both sides. So because it's double leg, so you multiply 3, and if it is triple leg, then you multiply with 3, and if it is single leg, then you multiply with 1. So in this calculation, it is double leg, so multiply with 2. And once you have that, you can find that Vs in this case will be equal to 3630 pound, and this will be equal to 36.3 kips, and phi is equal to 0.75. And so if you multiply them together, phi Vc plus Vs, and you will get here 0.75 multiply with 75.14 plus 36.3, you'll get here 83.6 kips. So your answer is 83.6 kips. So that's how you calculate the beam shear. Okay, so let's see, how did we start? We wanted to find what is the ultimate, or the uh, ultimate shear strength or design strength. Actually, this should be a design, should not be ultimate. This should be your design strength. Otherwise, you'll confuse with nominal shear strength. This is for design shear strength, which is 5 VN, and um, your design strength is 5 VN, and we know that VN is nominal shear strength, and uh, the shear strength is provided by concrete and the stirrups. And for concrete is use this equation, and then for stirrups we use Vs. And now for AV we need to remember that is it a single leg or double leg or triple leg, but in this case we provided leg at both sides, so it become double leg. And you may ask me, I said, Gideon, how does it look like single leg? So you have, let's say you have a beam, and then you have the main reinforcement over here, and provided. So in this one, this is your single leg. And then triple leg means you have 3 leg. So you have a beam, 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 and then you have the normal stirrups. So if you in this case this is a double leg because you have stirrups here, here, but then if you provided another stirrups here, then this become uh, triple leg. Okay, so that's how you have just have to pay attention. Is it a double leg, single leg, or triple leg, or fourth leg, depending on how many legs are used in your design. Okay, so in that, based on that, you'll have to pay attention whether to multiply with 2, multiply with 1, or multiply with 3. So in this case it's double leg, so we'll multiply with 2, and area of number 3 is 0.11. So that's how we solve for a beam shear. And then let's do another example for beam shear. And in this case, it said that what is the minimum shear reinforcement that you will need to provide for your stirrups. Okay, so here you said the first thing is you look at this equation and you'll see that FC is given to you, Fy is given to you, Vd is given to you, Vl is given to you. So if you directly use this equation, Vs equal to Av Fyd divided by spacing, then you'll see that you'll have problem. Because why? Because we know nothing about AV, whether it is double leg or single leg, and we know nothing about spacing, how much spacing you are providing from center to center. So which means that you cannot use this equation to solve for your Vs. Is there another way of solving it? um, yeah, there's another way of solving it, because we remember that Vd and Vl is given to you. So for a safe design, you know that phi Vn should be greater than Vu, and phi Vn is Vc plus Vs should be greater than Vu. So in this case, Vs should be greater than Vu divided by phi minus Vc. Okay, so now do you know Vu? We know Vu because we are given the dead load and life load. So we're going to use a combination, which in this case 1.2D plus 1.6L. And if you use this combination, you'll get 30 kips. And then do you know Vc? Vc is 2 lambda square root of Fc dash Bw d. We know d, we know Bw, and we know lambda is equal to 1 because it's, yeah, we'll generally use 1 unless it's by default lambda is equal to 1, which is normal weight concrete, unless it's specified that it's a lightweight concrete. Okay, so generally we assume that it's always normal weight concrete. Okay, and then once you have lambda equal to 1 and you put the value, and you'll see that this is equal to 26.29 kips. Remember that if you put all the value, this is, remember that this equation required you to be psi. Okay, so I'm going to divide by 1000 to get kips. So don't put FC is equal to, don't put here FC, don't put equal to 3 ksi. Instead, you should always keep the unit consistent with the formulation, because this formula is derived based on PS, or based on FC dash is equal to PSI. So please make sure that in equation in your concrete, the unit is very important. Once you mess up the unit, you mess up the whole equation. So all this empirical formula that, or all this formulation or the equation that you use from your FE manual, you have to pay attention to what unit you have to use. Okay, and the same from beam flexural also. um, any equation you have to pay attention what unit should you use for. So in this case, don't use 3 ksi, you have to use 3000 psi. And if you want to convert from from pound to kips, then you just have to divide it by 1000. Okay, so here in this equation, if you use vu, which is 30, and phi, we know that for a shear, phi is 0.75 minus 26.29, and you'll see that this is equal to 13.71 kips. Okay, so that means your shear stirrups for a safe design must provide a minimum shear capacity of 13.71 kips. So in this case, all you have to find is the close to the minimum is 14 14 kip. Okay, and then you may ask question, so is it wrong to say 83? It's not. Is it doesn't mean 83 is unsafe? No, 83 actually it's safe. 117 is safe. 169 also it's safe, because the minimum is 13.71. So all these are safe design for stirrups, but the question is asking for the minimum. So what should be the minimum? So the minimum is 14 ksi, 14 kips. Okay, and if in your concrete design, uh, there is a maximum limit of how much you can provide stirrups. So, but which is not part of your FE manual. But if you have to design for your concrete, there's also a limit of how much VS you can provide. The code ACI 318 has note down, or show you the value, um, how much is the maximum VS that is it can be used or permitted to use. Okay, so that's all of about beam shear. Thank you.